This video clip shows the physical implementation of a dual-band wireless telemetry system before the DPSK demodulator. The FPGA generates the required raw digital data, reformatted into proper transition edges, and feeds that to the PSK transmitter. On this fixture, we have 4 separate boards. They are data transmitter board, power transmitter board, data receiver board, and power receiver board. The data transmitter and power transmitter are Class E based transmitters, meaning on the data transmitter we have a Class E amplifier driving the small coil taped at the center, surrounded by a larger coil, and that's driven by another Class E amplifier on the power transmitter. On the power receiver side, we receive the power signal, rectifies it, and recovers a 10-volt output while delivering 100 milliwatt to our load. And at the same time, we also recover this 2 megahertz signal carrier information. We use it as the reset clock for our integrators at the DPSK demodulator. On the data receiver board, we have a low order filter that filters the received signal on the data coil, and the output will eventually go to the DPSK demodulator and serves as the input signal. So the whole system, including the FPGA, the telemetry link, and the DPSK demodulator, when we run this whole system, we can prove that data and power can be transmitted wirelessly. Well, although you've seen more wires than the rest of other things in this setup, but the main idea is the power signal, data signal, and the clock signals are all transmitted wirelessly and recovered properly. And that's how we get the previous 2 videos. It's by running this whole setup. At the end, I'm going to refer to some parameters of this whole setup. The power carrier frequency is 2 megahertz. The data carrier frequency is 20 megahertz. The data rate is 2 megabit per second. And the power efficiency is above 60% while delivering 100 milliwatt. And that will conclude this short presentation.